Welcome back to Mr. Greenstein's Geometry. We're in Chapter 11 in Section 8, Surface Areas and Volumes of Spheres. So a sphere happens to be a figure that is curved. It has a center, and the point is equidistant from all the points on the sphere. It has a radius, and that's the distance from the center to any point that's on the sphere. A chord is some segment that goes from on the sphere to some other place on the sphere. And you can see that the diameter goes all the way across. It's a chord that goes all the way across through the center of the sphere. The great circle is a cross-section created by a plane intersecting with the center through the sphere. So the great circle is the largest circle that you can create by making a cross-section across the sphere. A hemisphere is just half of the sphere created by a great circle. So it's like cutting your sphere in perfect half, and that's called a hemisphere. The surface area of a sphere is simply this. It's just the formula for an area of a circle with the same radius times 4. So the surface area of the whole sphere is 4 times the radius, or the area of the great circle. The volume of the sphere is this strange thing, in which you're just going to have to memorize. It's 4/3 pi r cubed. 4/3 pi r cubed. And this could be explained with calculus fairly easily, but we don't know calculus, so we're just going to have to take this formula as it is. Let's compute the surface area and volume of the soccer ball on the left-hand side. So if we were to compute the surface area is just 4 pi r squared, so 4 pi, and then we have 4.5, and that's squared, and that's going to give us 81 pi inch squared. If we compute the volume is that formula that I told you have to memorize, 4/3 pi r, which is 4.5 cubed, and then that turns out to be 429.41 inch cubed. The problem on the right-hand side is a cylinder, but it has a hemisphere cut out of the top of it. And it's hard to see that, but that's what the dotted line is supposed to show, is that there's a hemisphere cut out of this top part. And you were to come up with the surface area. Well, the surface area is going to be the lateral area of this cylinder. It's going to be the base area of the cylinder, and then it's going to be the surface area of a hemisphere. So you're going to have to compute that. The volume is going to be the volume of the cylinder as though it were all whole, and then you're going to subtract out the volume of a hemisphere. And we'll discuss this more when we get together next time.